Hello students, today we are going to study a topic remainder theorem which comes under the subtopic of binomial theorem. It is one of the application of binomial theorem. In these type of questions we have to find the remainder when some big number is divided by a given number. So let us start the concept. So if somebody asks what is the remainder when a plus b whole cube is divided by b. So if I write it like this and if I cancel it, then conceptually this seems wrong. But if I open it, the numerator, I'll obtain this thing a cube plus b cube plus 3a square b plus 3ab square whole divided by b. And if I bifurcate it, I'll obtain this step and we have to find the remainder. So suppose if I am dividing any number by 8, the minimum number that I require in numerator is 8, and in that case remainder is 0 and the number is completely divisible. Other than 8, if any multiple of 8 is there, in that case also the remainder will be 0. Going by the same concept, in all these three terms the remainder will be 0 and we'll be left with a cube divided by b, and hence here a cube is not divisible by b, hence remainder will come out as a cube. So coming back to our first step, if I cancel b with b, I'll be left with a cube by b, and in that case our remainder will be a cube. So going by the same concept, if a question is given to us like this, find the remainder when 17 raised to power 17 is divided by 16. So I can write 17 raised to power 17 as 16 plus 1 raised to power 17 divided by 16. So I'll open the binomial expansion of this and I'll obtain 17c0 16 raised to power 17 1 raised to power 0 17c1 16 raised to power 16 1 raised to power 1. Going like this, I'll obtain 17c17 16 raised to power 0 1 raised to power 17, and in denominator of all these terms I'll be left with 16. So 17c0 is 1 and this is 16 raised to power 17. Similarly, in the next step I have this, and in the last step I have this. So when all of this is divided by 16 and I'll bifurcate this, I can see that to make the remainder 0, since denominator is 16, what I need 116 in the numerator. So the first term, the second term, and all the term except the last term will have one of the 16 in them. So in this case remainder is 0, in this case remainder is 0, going like this till the second last term. Here remainder is 0 except the last term. Here I am left with 1 divided by 16. Since 1 is not divisible by 16, hence remainder is 1. So in order to solve such kind of questions, what we can do, we can simply cancel 16 with 16 and we'll get 1 raised to power 17, which is 1 upon 16, and hence our remainder comes out as 1. Let us take second example. Find the remainder when 17 raised to power 17 is divided by 15. In the previous question we saw that we broke our 17 as 16 plus 1 divided by 16. Why we did that? Because our denominator is 16 and hence to make remainder 0 I need 116 in the numerator. Right now our denominator is 15, so I'll break my 17 in such a way that I should get 15. So I'll write my 17 as 15 plus 2. So now what I'll do, I'll break 15, I'll cancel 15 with 15, and I'll obtain 2 raised to power 17 divided by 15. Now I'll have to think of such number which goes as near as from 15. So 2 raised to power 17 can be bifurcated as 2 raised to power 16 into 2 raised to power 1 divided by 15. Why? Because 2 raised to power 4 is 16, which can be again bifurcated as 15 plus 1. So 2 raised to power 4 is 16, and I had 17 power, but I have to make 4, a group of 4 out of it. So all the 17 powers won't be utilized, so I'll break it in the power of 16 and 1. So now I can write it as 2 raised to power 4 raised to power 4 into 2 raised to power 1 by 15. This 2 raised to power 4 can be written as 16 raised to power 4 divided by 15. Now again 16 can be bifurcated as 15 plus 1. And going by the same expansion method of binomial theorem, I can cancel out all the terms having numerator 115 at least, and what I'll obtain in the last, 1 raised to power 4 into 2 raised to power 1 by 15, which will give me 2 by 15, and 2 is not divisible by 15, hence my remainder is 2. Let us move to the next question. Find the last 2 digits of 75 raised to, let us make it 74 raised to power 20. Now how do I find the last 2 digit? Suppose there is a very big number, and in the last I have 98. When I am dividing it by 100, in the end I am getting some number and last 2 digits are 98. So suppose that number was 4, so 498. So going by like this, the unit digit of the quotient will be 4, and I'll obtain the last 2 digits as 98. So in order to obtain the last 2 digit, we divide the given number by 100. So in this question, I'll divide 74 raised to power 20 by 100. The process is still the same. We have to break 74 in such a way that we should get 100. One multiple of 100 in it. So 74 can be written as 100 minus 26 raised to power 20 divided by 100. So all this term will be cancelled. Minus raised to even power is positive, so we'll get 26 raised to power 20 divided by 100. Now I have to make 26 one such number which should be as nearest as possible to one of the multiple of 100. So 26 square is 676. So 26 raised to power 20 can be written as 676 raised to power 10 divided by 100. So I can now break 676 as 700 minus 24 raised to power 10 divided by 100. Now negative number raised to even power is positive, so I'll get 24 raised to power 100 divided by 100. Again I'll make 24 raised to power 10, this is 10, as 576 raised to power 5 divided by 100. Now this can again be rewritten as 600 minus 24 raised to power 5 by 100. I'll cancel 600 because after opening the binomial expansion, all the numerators bearing 600 is completely divisible by 100, which will leave us remainder 0. So I can directly cancel 600 by 100. So now I am left with minus 24 raised to power 5. Negative number raised to odd power gives me negative number. So I'll take the negative outside, and this can be written as 24 raised to power 5 divided by 100. Now 24 raised to power 5 cannot be completely utilized in formation of perfect square. So I'll write it as 24 raised to power 4 into 24 raised to power 1. Now 24 raised to power 4 can again be rewritten as 576 square, 576 square into 24 divided by 100. Now this can again be rewritten as 600 minus 24 square divided by 100. This will be cancelled out. Negative number raised to power, even power is positive, so I'll obtain 24 square multiplied by 24 raised to power 1. This is again 576. 576 can again be rewritten as 600 minus 24. Now I'll cancel this. So now I'm left with minus 24 multiplied by minus, which is plus 24. 24 into 24 divided by 100, which gives us 576. So the last two digits are 76. Let us move to the last question. Find the product of last two digits of 1919 raised to power 1919. Now this question can again be solved by dividing by 100, but since the power here is too big, I'll need to use the binomial expansion in this question. So I'll write 1919 as 1920 minus 1 raised to power 1919. Why I am using the binomial expansion in this question? Because we can again write 1919 raised to power 1919 divided by 100, but that will be very lengthy process in this question, because now I'll be left with 19 raised to power 1919 divided by 100. So now I'll need to calculate the square of 19, and then in the next step I'll obtain 361, which will be rewritten as 400 minus 39. So after that I'll need to find out the square of 39, and since the power here is too big, I should avoid this process and I'll rather use the binomial expansion for this question. So I'll write 1919 as 1920 minus 1 raised to power 1919, and I'll open the binomial expansion for this power, and I'll obtain 1919 C0 1920 raised to power 1919 1 raised to power 0 minus 1919 C1 1920 raised to power 1918 1 raised to power 1 plus 1919 C2 1920 raised to power 1971 square, going like this. The last term will be 90, second last term will be 1919 C1 1920 raised to power 1 1 raised to power 1918, and last term will be 1919 C the second last term will be 1919 C 1918, and the last term will be 1919 C 1919 and 1920 raised to power 0 and 1 raised to power 1919. Since all these numbers which are starting from the beginning will have very huge number in them, so we don't need to calculate them. We'll just focus on the last number. So 19 C 1918 can be rewritten as 1919 C1 into 1920 minus the last number 1919 C 1919 can be written as 1919 C0, because we know that NCR is equal to NC n minus R, and this will be 1 and this will be 1. So in order to find the last two digit, we need to focus on the calculation of these two numbers. So these two numbers will give me 1919 into 1920 minus 1. So we need to calculate the last two digits of this number. So I'll obtain some number here and some number here. So the last two digits in this in the product of 1919 into 1920 is 80. So the last two numbers in this 1919 raised to power 1919 is 79. So the question is asking us to find the product of last two digits. So the product of last two digits is 63. So this is one of the subtopic of binomial theorem, which is called as remainder theorem. Thank you.